Any number of practical applications in computing require things to be in order. Even before we start computing, the importance of sorting is drilled into us. From group pictures that require the tallest people to stand in the back, to the highest grossing salesman getting the largest Christmas bonus, the need to put things smallest to largest, or first to last, cannot be underestimated. As you probably might have guessed, sorting algorithm is an algorithm that puts elements of a list in a certain order. This is an example of using a sorting algorithm called the bubble sort. In this algorithm, each pair of adjacent elements is compared and the elements are swapped if they're not in order. The importance of using a sorting algorithm lies in the fact that data searching can be optimized to a very high level if the data is stored in a sorted manner. Imagine taking a group of people, giving them a deck of cards that has been shuffled, and requesting that they sort the cards in ascending rank order. Some people might start making piles, others might spread the cards all over the table, and still others might juggle the cards around in their hands. For some, the exercise might take a matter of seconds, for others several minutes or longer. Some might end up with a deck of cards where spades always appear before hearts. In other cases, it might be less organized. Fundamentally, these are all the big bullet points that lead people to debate the pros and cons of various sorting algorithms. When comparing various sorting algorithms, there are several things to consider. The first is usually runtime. When dealing with increasingly large sets of data, inefficient sorting algorithms can become too slow for practical use within an application. It looks like the select sort is slower for this example. A second consideration is memory space. Faster algorithms that require recursive calls typically involve creating copies of the data to be sorted. In some environments where memory space can be at premium, certain algorithms may be impractical. In other cases, it may be possible to modify the algorithm to work in place without creating copies of the data. However, this modification may also come at the cost of some of the performance advantage. A third consideration is stability. Stability, simply defined, is what happens to elements that are comparatively the same. In a stable sort, those elements whose comparison key is the same will remain in the same relative order after sorting as they were before sorting. In an unstable sort, no guarantee is made as to the relative output order of those elements whose sort key is the same. In this video, I have only scratched the surface of sorting algorithms, and there will be other videos in this channel going through the details of each part of sorting algorithms.